Hi guys! Today I'm going to be doing revision on parallel and perpendicular lines for maths, and that includes how to find the equations for them on graphs and also some angle facts related to them. Right, so on the left here we have a pair of parallel lines, which means that they both go in the same direction, so they'll never meet at any point, they'll always be the same distance apart from each other. And you can see that they're parallel because of the two arrows on them both going in the same direction. And then at the right we have a pair of perpendicular lines, which just means that they cross each other at 90 degrees. So first of all we're going to be talking about finding the equation of a line that's parallel to another line on a graph. So here we have the graph of y equals 2x plus 1, and then to find the equation of a line that's parallel to it, we need to look at the end bit, the plus 1, which is called the y-intercept. It's how far up the y or down the y-axis it is, and that's the bit that changes for parallel lines. And no matter what you change that value to, it's always going to be parallel as long as you leave the 2x, which is the gradient, alone. So in this case we have y equals 2x plus 2, and also here y equals 2x minus 1. And you can see that both of them lines are parallel, and they would be no matter what that number is. Whereas with perpendicular lines, it's the gradient you're interested in. So in this case, the 2x out of the y equals 2x plus 1 equation. And what you have to do is you have to times it by minus 1 over whatever the number is. So in this case, the number in front of the x is 2. So we do minus 1 over 2. So that's minus a half x. And the plus 1 stays the same, so you get minus a half x plus 1. And here's what it looks like when minus a half x plus 1 is drawn on the graph. And as you can see, I've marked the 90-degree angle on, which shows you that it is perpendicular, so you've got the right equation. And this is again the same no matter what the equation is, including if there's already a minus or a fraction in the equation, you can still work with that. So in this case we have y equals minus a quarter x plus 1, and again we're going to times it by minus 1 over what your number, which in this case is minus a quarter. So you do a minus times a minus, which is a positive, so that gets rid of the minus, and then you do 1 over a quarter, and if it's a fraction already that means you just flip it upside down, so which gives you 4 over 1, which is just 4, so your gradient is 4x. And as you don't change the intercept, it stays plus 1. So here's what y equals 4x plus 1 looks like on a graph, and if you look carefully, the angle between them is 90 degrees, which means that you've got the right equation. Now we're going to be looking at some angle facts, 3 of them. They're all related to parallel lines, so we've got a pair of parallel lines here, which remember is shown by the 2 arrows on them. So the first one we're going to be looking at is alternate angles. So as you can see, we've drawn a line that goes straight through the 2 parallel lines and marked 2 angles on, and if you can imagine the angles being the corners of a Z shape, so that comes along the top parallel line from the right, down, and then left along the bottom parallel lines like a Z shape, and then 2 angles are at the corners of it, and that's how you work out if 2 angles are alternate. And if they are alternate, then they have to be equal. So if one's 72 degrees, for instance, then so's the other one. And here's a pair of alternate angles on the other side of the line. And if you look, you can still see that Z shape. It's just the other way around now. Now we're going to look at corresponding angles, which are also equal, so equal the same number. And this time you can imagine a sort of F shape that these 2 angles at the corner of. So in this case it would be a backwards F, and here's another pair of corresponding angles. In this case it would be an upside down F, but you can still see that F shape, and if you can see that on a diagram it means that they're equal, so if one's 72 degrees so is the other one. And the last one of the angle facts for parallel lines is co-interior angles, and here you can see they're at the corners of a C shape. So in this case it's a backwards C, and these add up to 180 degrees between them. So if one of them is 70 degrees, then you do 180 minus 70, which is 110. So the other angle is 110 degrees. And often if you get a question that relates to these angle facts in an exam, then it will say give reasons for your answer. You need to look out for this because you won't get all the marks unless you do. So if you've done a calculation that involves alternate angles, for instance, then you want to put in brackets afterwards alternate angles are equal. So, you put in your reason behind how you worked out your answer, and that'll give you some extra marks on the question. And that's everything for today. So if you enjoyed this video, don't forget to like and subscribe. And if you have any other revision videos you want me to do, particularly for the exams after half term, then tell me in the comments, and I will see you next time. Bye.